So hello everyone, let's solve this problem LRU cache. So this problem is more of a data structure problem instead of competitive problem. So in this problem we have to create a cache. Okay. So we have to create a cache and there are two functions, put and get, and both are run in constant time. Both this get and put can run in constant time. Okay. So time complexity of this put and get method are big of 1, and we have to generate this type of caching. So let's take an example and look at the how we are going to generate the cache. So first of all, we have given a capacity. Okay, so let's take capacity of our cache is 3. Okay, left. What we are going to do is, this is left side, this is right side. Let me just erase this. This is our right side, this is our left side. Okay, so now what I am going to do is, this is our cache. So what I am going to do is, I will append the elements in this array. So first of all, I will get put 3. Okay, so first of all I get a put 3. So I always put any element in the left side. Okay, so I will always put any element in left side. So I will put 3 over here. Now I am getting element 1. Okay, so now I will always put new element into left side. So already there is a 3, so I will going to change the 3 over here and 1 over here. Now again put. So put is equal to 2. So now again we will change this values. 3 comes over here, 1 comes over here, 2 comes over here. Okay. So now I have get a value get 3. So now I want a value 3. Okay. So get 3 means I want a value 3. So now what I am going to do is, if 3 is in our cache, then I will delete this 3 and then add it to our cache. So I have deleted 3 from over here. Now I am going to add this 3 to in our cache. So how I am going to add this? So I will just first remove 1 and put over here. Sorry. So I put 1 over here. Then I will remove 2, put over here. Then I will put 3 over here. So this is how we have put 3. Okay. Now again I have a new element comes. I have to put 4. But over here our capacity is full. We are not able to append any elements in this element. So now what I am going to do is, I will delete a right side of element, rightmost element. So I have deleted 1. Okay. Now what I am going to do is move the element. So 2 comes over here, 3 comes over here, and I have added 4. This is the idea of creating cache. So now how we are going to implement this, and all the operation in big O one time. So to solve this problem, what I am going to do is, I will use a doubly linked list problem. So what is the doubly linked list? The doubly linked list has 2 pointers. So suppose this is our doubly linked list node. So this node contains key value pair, and this is previous and this is next. Suppose there is node over here and there is node over here. So next will point over here and previous will point over here, and this value contain key. So this is doubly linked list node. So we are using doubly linked list node to solve this problem. Okay. So let me just create a doubly linked list over here. Okay. So I am just creating a doubly linked list. This is the left. So I will call this as a left. Okay. So this is next element is initially this next is pointing to the right of our doubly linked list, right doubly linked list. If the our caching is 0, empty, so this is right. Okay. So and right is pointing to the left. Okay. So this is previous, this is our is next. So initially left next is pointing to the right, and right previous is pointing to the left, and this is pointing to the none, and also the over here this is none. So right next is none and left previous is none. Now what I am going to do is, if I have get our size of the size of our linked list, size of our caching is 3. So now what I am going to do is, we will first of all we have to put 3 and 4. So what is the 3 and what is 4? Let me change it. 1a. So 1 is the key, 4 is a value. So we have getting a key value pair as an input. So 1 is a key and 4 is a value. So now as we seen in a array example like over here, so what I am going to do is, we will append this in the leftmost side. So we are going to append over here. Okay. So I am just appending over here. So okay. So key is 1, so I have written 1 over here, value is a written over here. Now what I am going to do is, I will changing the pointers. So left pointer is pointing to the our node, and previous right previous is pointing to our node. And now our node is next is pointing to the previous, and left right previous, and our node, this node previous is pointing to the our left of a node. Okay, so this is how we have added the first node. Now we are getting put is equal to 2b. So now we are getting a 2b. So now again what I am going to do is, just me wait a second, I will just remove this. Okay, so now what I am going to do is, I will writing this in a just over here. So now what I'm going to, this is the this connection is already made, and now we want to add the element, so we can add over here. Okay, so I will write 2b. Now what I'm going to do is, change this as over here. Now I'm creating these two, and over here like this. So we are creating these two, so we are modifying only 2 pointers, 4 pointers. So modifying the pointers take big of 1 time. Okay, so this is how we are going to add this node over here, left side. Now again, if we again we have put is equal to 3b, 3c. So now what are we going to do is, we will add over here. So and we will change this and remove this, and then again creating another new connection. So 3 is added over here. This is how we are going to solve this problem. If I want a value of like get 1, if we will check whether 1 is in our cache or not. If 1 is in our cache, then what we are going to do is, we will just remove this one. Okay, and then we will add over here. Over here, let me change the color. So we will add 1 over here. Okay, so this is how we are going to solve this problem. So let's code this up, and you can understand more while coding. So let's first of all create a class. So for a node, okay, sorry. So create init method and id self and key value pair. Okay, now self dot equal to key, self dot val equal to val, self dot next equal to self dot previous equal to none. So we have created doubly linked list by using this class, node class. Okay, now let's assign, let's create some variable. Capacity is equal to capacity. Okay, now self dot let's create left and right pointer. So left is equal to node of 0 0 containing 0 0, self dot right equal to node 0 0. So we have created this left and right node over here. Now let's create a cache. Self dot cache.
So what is this cache is? Cache is like our dictionary, but instead of dictionary, uh, uh, cache is like our array over here, but instead of array it's a dictionary. So this dictionary contains each and every element of our, like if one is in our if this node is in our caching system, then we will store this in our cache variable, cache dictionary. Okay, so that's why I have created this cache. Now let's write a put code. So how we will going to put some element if we are getting one a as an input. So what we are going to do is we will check if whether our uh, key is in our if if our element is already in cache. So first of all we will going to delete this element. So if in it's if it will already in our uh, caching system, then we will delete this. So suppose there is a one function called delete. So delete, and we will self dot, we will call this function and passing this key. So by using this our key will be deleted. After that what we are going to do is we will create a new node. So for creating new node, so node equal to uh, node, and we will passing key and value, okay, as a input. Now what we are going to do is we will going to insert this node into our caching system. So before inserting this cache into our caching system, let's change the cache address. Self dot cache key. So we'll assign this new node into our cache variable, cache dictionary. Now what we're going to do is we will insert this node into our cache. So self dot insert node. So we just by using this function we are just inserting our element. So we will write this insert and delete function later, but suppose there is one function who insert our element in this our cache and delete the element from our cache. Now we will check whether if len of self dot cache become greater than capacity. Okay, if it's become greater than capacity means we have added extra element. Then what we are going to do is we will delete this node. So we will delete this node which is right previous. So what we're going to do, let's take uh, uh, rightmost node. Okay, this is rmn is equal to rightmost node. So what we're going to do, self dot right dot previous. So this previous contain address of this node. So rmn is equal to self dot right dot previous. Now we will just delete this node. So self dot delete delete rmv, and then also we will delete from our dictionary cache and self dot cache rmn dot value. So why I have used value, because we want to instead of value I have to use key. Okay, so by using this we are getting a key. So this is node, we are getting this node. So by using this we are getting a key. So by using this statement we are deleting from our catching our in our cache. Now let's write get function. If key is in our self dot cache, if key is in our cache, then what we are going to do is then we are going to return the value, otherwise we will just return -1. Okay, if just write if key is not in our self dot cache, then we will just simply return -1, because we are not finding any key which is in our caching system. If not, then we are sure that there is one value in our key. So how we are going to get this value? So first of all, we will go self dot delete uh, self dot cache key. So first of all, we will just delete this node. Okay, then we will just import insert this node into our cache, and then key, and then we will just return the value of this self dot cache dot key dot value. So by using this, we are returning a value. So this portion gives us node address. So this portion gives us a node address, like over here, giving us node address, and after that node we are want to return value. So by using this, we are returning a value. Okay, this is the code. Now let's create a delete and insert function. So that delete getting self and node as an input. Okay, so what we are going to do, suppose we have to delete this node 1 and a. So how we are going to do this? First of all, we are getting this previous node address and next node address. So how we are going to do this? So let me write previous and next equal to, so let me write nxt instead of next. So how we are going to get this previous address? So node dot previous, and how we are going to get this next index? So node dot next, we are getting this, and after that we are just now what we are going to do is we will just pointing, what we are going to do is we are just pointing this to this and this to this. So we are just deleting node by the, using this. Okay, so let me first of all write this to this. So previous dot next equal to, this is our next, so nxt, and nxt dot previous equal to previous. So by using this statement, we are deleting this node. Okay, so we are deleting this node by using this two statement. Now let's write insert function. So def crt self, and we are getting node as an input. So every time we have to import any node before over here. So we have to, every time we have to import the node over here. So how we are going to import the node over here? So we know the address of this node. Sorry. So we know the address of this node. So now what we are going to do is we are getting the address of the we call this as previous node. Okay, so previous is equal to self dot left. Okay, so it always becomes self dot node. Now we are getting the this node address, call is next. Nxt is equal to self dot left dot next. Okay, we are getting a previous and next node element. So now what we're going to do is we are changing the value. So first of all, let's change this node value. We will assign node dot next equal to nxt and node dot previous equal to previous. Okay, now we will change this these two nodes address. So this next previous dot next equal to node. So previous dot next equal to node, and now next dot previous equal to node. By using this statement, we are changing these two value, and we are adding the new node over there. Let's run this code for any compilation error. So over here we are getting none type object have a preview. So why we are getting this? Okay, we forgot to assign self dot left equal to self dot left dot next equal to self dot right, and self dot right dot previous equal to self dot left. So initially our left and right is empty. So our left and so like this is our left and this is our right. Okay, so initially left is pointing to the right and right is pointing to the left. So initially this is the situation, and this part is pointing to the null, this part is pointing to the null. So I have just write over here. Let's run this code for any compilation error. So rvn. So let me write this rvn. Okay, let's run again. Okay, let's submit this code. So as you can see, our code is submitted. Thank you for watching this video. Please like this video if you feel this content is good, and it will take lot of time to write this code and remember this code for me. So please like this video, if possible comment this video and subscribe me. Thank you for watching this video.